So welcome back everybody, my name is Dustin, and in the last video we started getting into or adding in ImGui to our game engine, and we were able to get the demo window going, alright? And there was a small challenge at the end of the video, and that was for you guys to create a ImGui DockSpace. So let's just close this down. The cool thing about ImGui is for most things we can just go to the ImGui demo.cpp. It has complete examples of how we can set things up. If you search for, so just hit Control-Shift-F, and then you hit, say, show example app doc space right here, and we'll just go to the function. Let's find this in here. Right here. So we go here, it says read this here. So this demo is more complicated than what most users normally use. If we remove all the options, then it would just be this here. In reality, that's all we really need to get a dock space going on our viewport. But we're going to go over this really quickly. So it's just showing like you have your full screen, the padding, flags if you want to set different flags, right? You see you're getting the main viewport here, window position, all this stuff. This is how you set up a dock space manually. So it goes over all the different features that you can add to the dock space. But we don't really need that. All we actually need is this here. Where is that? This here. Show example dock space. So if we just copy this and take this into our application, and let's go to our render ImGui here, and right above show demo window, we'll just add this in here, and let's run it. All right. Basically, you see here, it shows us our back screen. We're not seeing our stuff anymore because this is rendering over top of it, but our stuff should still be there. If we grab the demo window, we should be able to drag it in, and we can. We'll just put it off to the side here, and we'll just drag this a bit bigger. Cool. All right, that's it. That's it. We got a docking space going. We have all this open space. What I want to do now, first off, is let's make this window larger. I want to be able to render the scene in here. So the scene that we have in the back there, right? So if we were to move this or stop rendering it, we should still have our scene there. So where is our, inside of our render function? Right here. So if we just stop this for a second, we should still see our scene in the background. Yeah, so we still have our scene here, right? Now, this is taking up the entire window here. And what this is actually taking up is the OpenGL default frame buffer. So what we need to do before we start looking into what to do with this, we need to actually get into what frame buffers are, okay? So we'll talk about that in a couple minutes, but first let's make this window the size of our display here, okay? But I want to actually keep the resolution of the game to 644/80. So we'll have to do that as well. So let's put this back because we want to be rendering our dock space. And let's actually go into this real quick. And we'll keep the demo window for now, just so we have another window for docking. And then right here, we'll just say to do, and we want to go add new scene display. So we're going to eventually get into that. That's the goal, is to render all of the scene into a ImGui window, and then we want to be able to dock that window. So we'll have to get in. We'll get into that. All right. So up here, where are we doing this? In our window. So we have our window right here. We're creating our window, and we are hard coding it to 644/80. But what we can actually do is get the display size of the window. So we want to go SDL display mode, display mode. Let's see, or display mode, and we'll say display mode, and we want to send that into SDL get current display mode, or display mode. Okay. We open this and it asks which display index that we want, and we want display index 0 because you could have multiple displays. And we got to send in a pointer to our display mode, so that's going to be the address of display mode. Cool. So from there, we're going to get our actual display, and we're just going to say display mode dot w for our width. Move this over here, dot height. And for now, we're going to, should we keep this as centered? It may go to 0, 0. We'll leave it there for now. Okay, and that's good. Let's just see what that does for us. Awesome. So that's going to be our whole screen there. All right. And we can undock this and put it here if we like, move it around. Cool. So let's close that. So we can go SDL window maximize. Let's see what that does for us. Run it one more time. Cool. All right, that's exactly what I wanted. You see how I have my title bar here for the main window? That's what I want, okay? So close that down. So we want to make sure that our camera and everything is still running at 644/80 because that's what the resolution I want for our game. So where do we put our camera in? Camera 2D. Cool. Where do we create our camera? Yeah, so we're just creating a temp camera here and it's default, and I believe we have a defaulting to 644/80. And where is our default constructor? Yeah, so 644/80, and that's fine. That works for us. Let's go back into our application.cpp, wherever that went, right here. And let's go to our render function. Just take a look here. So first thing we want to do now, so in order to be able to render our current game scene into an ImGui window, we need to start looking into frame buffers. So what is a frame buffer? A frame buffer is a collection of buffers that can be used as a destination for rendering, basically a type of render target. So instead of the main display, so you have your OpenGL, it has a default frame buffer. So the window has a buffer to it. You're rendering to that target. OpenGL also has user created frame buffers. We're basically rendering to a texture. And the user created frame buffers, they're called frame buffer objects, or FBOs. The frame buffer will have its own texture, and when we bind the frame buffer, all the draw calls that are being done while it's bound will be drawn to the frame buffer texture. That way, we can take that frame buffer texture and draw that texture into an ImGui window. So you're basically just using an ImGui image and using that, okay? So the first thing I guess for us to do now with frame buffers is to start our frame buffer class, and we're going to do that in our Scion renderer project. So let's go to that now. So here, rendering and buffers. We're going to go add new, and we'll start with the H file, and it'll be frame buffer.h. Cool. Now that we're here, we can go include, and we want to have glad, and we're going to have memory. So include memory. And we're also going to want to get our texture for the texture class. And I believe that's in here, texture. Cool. All right. So let's just open up something over here. Let's actually just open up texture. Essentials, texture. Oh, that's vertex. Texture. I need this here, the namespace, Scion rendering. We'll copy that. Paste. Cool. All right, let's start our class, and it's a frame buffer. And it's going to have some private variables and functions, and it's going to have your public. Okay, so we'll start with our private variables, and the first thing we're going to want to have is a GLUint for the frame buffer object, or the FBO, and we'll say FM FBO ID. We want the ID GL. This should be a capital. Okay. We also want one for the render buffer object. You don't always need a render buffer object, so we're going to add a flag to the constructor for a render buffer object as well. We won't create it unless we want to create a render buffer object. We'll get over that. We'll go over render buffer objects shortly. So that'd be MRBO ID. Cool. Now we're also going to need a shared pointer to a texture because each frame buffer will have its own texture. In our case, that it's going to be using. Okay, so std shared pointer, and it's going to be a texture, and it's going to be our MP texture. We're also going to need the width and the height for the texture and the render buffer object if we are using it. So we need to go int m width, m height. Cool. Then we're going to have those two flags that we were talking about. Well, we're only talking about the one for the using the RBO, or render buffer object. The other one is going to be for resizing, okay? And we'll go over that as well. So bool MB should resize, and we want MB use RBO. Cool. Let's have a private function, and that's going to be initialized. Will be bool initialize. Awesome. So just like a lot of different things, we're going to have our frame buffer constructor. Frame buffer constructor, there's going to be a default, and then we'll have frame buffer, and it's going to take in the width and the height. Width, int height, and it's also going to take in if we're using the RBO or not. So we use RBO. Awesome. And then our destruct. Frame buffer destruct. Cool. And this one's not going to be default because we're going to have to do some things inside of that. Okay. And then we're going to have two other functions. It's going to be void resize int width int height. So what height do we want it to resize? And then we're also going to have a void check resize. Now I'll go over the reason why I'm having two of these functions right now involving resize later on. Okay, resize. Cool. And then we just want to have some getters. No setters though, because everything for setters needs to be done internally. We don't want to change that from the outside. Okay, so we just want to say, we'll say inline. You don't have to in most cases. It's implied usually or implicit. But we'll say get ID and const return FBO ID. We're never going to need the RBO ID. That's going to be internal as well. The RBO will attach to the frame buffer, and we'll go over that shortly. Then inline const GL uint get texture ID, because it will have its own texture as well. And the texture is a pointer, so we want to make sure if not MP texture, we just want to return 0. And else return MP texture get ID. Now you could probably just put this into a ternary, and that's exactly what we're going to do. Instead of this if here, we'll just do a check. So MP texture, keep that there. Ternary operator. If it is, we'll take this, we'll say return 0. 0. So we need to do this. Sorry guys, this needs to be return there, just like that. Cool, cleaner, good to go. Then we say inline const int width, or get width, up to you. And then we want to say return and width, and then same for height and height. Awesome. Okay, now we just want to create one function first here. So we create our framebuffer.cpp. I was showing a little trick here, because before we would create all the functions and then move them all and have to erase them all. Now I can just take out this one and go namespace, put the one function in, cool, and then go back to our frame buffer and now create all of these, and they'll all go automatically into our namespace. Create declaration definition, and they all should go in. Cool. All right, they're all in there, nice and clean, and much faster than I was doing previously. Okay, so we do this, just spread these out a little bit. Okay, cool. So first thing, before we go into initialize, let's just go into our constructors. Our default constructor will just call frame buffer, and it'll set in some default sizes. So the default is just going to be 640, 480 for a default size. And you could have this whatever you want. Your default size can be maybe create some constants and put those in, const expr, or you can just put it in hard code it like I'm going to do for now. And false this for use RBO, so we're not going to use RBO by default. And then down here, we want to make sure that we set everything. So it's M FBO ID. We're just going to set this to 0. M RBO ID 0. And then we want our MP texture to be null pointer to start. Go to the next line. The width will be the width that's passed in. The height will be the height that's passed in. And then go down another line. That will just be MB should resize. That will be false by default. And then we'll have the MB use RBO. And that will be the B use RBO. Cool. So the first thing we want to do inside of the actual frame buffer here is create the texture. We already have the texture loader, right? So we want to actually add to that. So let's go up here and let's include, there's a few includes, let's include our logger first. Logger, just so we can log anything. And then we also want to include our loader and our texture loader. Awesome. So we'll say MP texture is equal to std move texture loader create. And this needs to take in the texture type, right? So it'll be texture type. And this one is going to be a frame buffer. Now we don't have that yet, so we need to go add that in. Frame buffer, and then this will take the width and the height. So we don't have a constructor that has that right now, or sorry, we don't have the create function that takes this in. We also don't have frame buffer for our texture type. So let's go add that in now. So Control C, copy the frame buffer, and then just hit F12 on top of texture type, which should take us right there. And we'll add this in right here. So it's a frame buffer for our texture type. And if we go back to our frame buffer, we want to go to texture loader create, and let's go into that. Cool. So we're going to have to make a few changes in our texture loader. Oh, I did add this here, create from memory. I started it for us. I didn't finish it, but we're going to go over that in another video. I already have this working in my main development engine, so I'll go over how to do it. Or you could try it as a challenge on yourself. So it's going to need a const unsigned image data. It's basically the same thing, but you're using data instead. Now, there are some changes we have to do to make that work, but I will show you guys in another video. Okay, so we're going to have another create function, and we'll just bring this down here. And this create function, we'll just put a space. This create function, it takes our texture type, but we're not going to need the texture path or the file path. Okay, this has to be different. What this needs here, if we get rid of this, it'll be int, that'll take in our width, and it'll take in our height. Cool. Now we have that function, and we can just make this function. And before we start working on this function, we're going to need another load function. You see how we have our load texture here? Well, we want to have another load function, and this one's going to be for load FB texture right here. So it's all going to be basically the same idea, but we're not going to need the file path. Okay. Now we're not going to use blended for now. We're just going to say static bool load FB texture. That's going to take in our GL UInd ID. And we'll send that in as a reference. Probably doesn't need to be a reference, but we'll send it in. And we'll say int reference. You could change that to a pointer if you like. And int reference for the height. Cool. And we'll create this one as, okay, so unlike the load texture function up here, we don't need to get the image data. So we don't need to load the image. That doesn't need to be called. We just need to bind the texture that we created, do the call here to text image 2D, and then set the texture parameters. That's all we need to do for the load frame buffer texture. So we can start that first. So we're sending in the ID. So we want to go GL bind texture. And this takes the target, GL enum target. So the first is target, and that's just going to be GL texture 2D. And then it takes in our ID. So we're binding the texture. Now this should be generated before we send it in, but we'll get to that. And then we need to set our GL text image 2D. Cool. That also takes in the target. So we'll say GL texture 2D. Then it also takes in here the level that we want, and we just want 0 for level. And then the internal format. In our case, we're going to be using GL RGBA. And then we want to take in our width and our height. And then for the border, we don't want any border, so just 0 for that. And then we also want for the format also to be GL RGBA. And then the type, so GL enum type is going to be GL unsigned byte. So basically the same as above there, except we're hard coding the formats that we want. We're not checking what the format is. And then right here, when it's const void pixels, we're not sending any image data in. So we can just set this to null for now. Okay. The reason why we're not setting any data in is because Basically, it's empty data, and we will be rendering, or any draw calls will be rendering to the frame buffer pixel data, okay? And now we want to set our parameters, and we can just copy these parameters for now, and we'll just copy the whole lot. Copy this, put it right here, cool. And we're not going to do blended for now. If we need to do blended, we'll do that later. So we can get rid of all that blended stuff here. Move this over. Cool. That's all we need to do. Then we go true. There's no real reason for this to be bool here because we're not going to be having any failures. So now that we have these here, we can go down and do our create function. So we have our create function here. And the first thing we're going to do, we want to make sure that the user is trying to create a frame buffer texture. So we want to say if the type sent in is not equal to the texture type frame buffer. So if it's not equal to frame buffer, now we can either assert here or have an error. For now, we'll just have an error. Scion error failed to create texture for frame buffer. Incorrect type. Incorrect type passed in. Cool. And then we just return null pointer here. We can add an assert here. We can go Scion. I believe I added assert. We do. And we want to say type is equal to the frame buffer. Now, asserts are great if you want to stop it right away so you can see where you're fixing something, but it's ignored in release mode. That's why we have the error here. Okay, so all your stuff should be checked in debug anyway. So assert frame buffer, and then we'll say a little message here. Must be frame buffer type. Awesome. So then if we made it to here, we want to generate our ID. So GL uint ID. And we're going to send that into GL gen textures. And it's just going to be one texture. And we want to send in the address, or because it takes in a pointer, because you can have multiple. So it just uses a pointer to multiple data, if that makes sense. And I want to say load FB textures. ID, and it takes in the width and the height. Cool. And once we've done that, we can actually just create our texture here. So returning a shared pointer, so we can say std make shared of a texture that takes in the ID, width, the height. The next one is the type, and we just send in the type, and then the texture path. Now it doesn't have anything for texture path, so we can just leave that blank. Cool, there we go. So that's creating our frame buffer texture for us. So now we can go back into the framebuffer.cpp. Okay, and this should actually work for us now. This should be there. Yes, perfect. Now that we have the texture, we want to check to see if the texture is null pointer. And if it's not, then we also want to call the initialize function, okay? And we want to check to see if that comes back as false. If the initialize function or the texture is null pointer, we want to throw an error there, okay? So we want to go if not MP texture or not initialize. Then we're going to want to say Scion assert for now and just be false. Failed to create frame buffer. Now we don't know why, but we know we have a problem there. And then we want to just say Scion error and just frame buffer creation failed. Cool. So now we actually want to go into initialize and do the initialization. Okay. So since we are creating a frame buffer here, the first thing we want to do is actually create a frame buffer. So we want to go GL create frame buffer. Okay. And this takes in the GL size I, or the number of frame buffers to be created. And we want to create one. Okay. And then it also takes in the frame buffer itself. So this is specifying the array where frame buffers are stored. So there could be multiple frame buffers. but we only have the one, so we want to send in the address of the FBO ID. And then we're going to want to bind our frame buffer, okay? So once we bind it, we can do things to it that we want. So GL bind frame buffer. And the first thing is the GL enum target, and that's just going to be a GL frame buffer. So GL frame buffer, and then it takes in the frame buffer ID that we want. So FBO, or frame buffer object. Cool. Get rid of this space here. All right, now that we have the frame buffer object, we need to attach the new texture that we created previously to the frame buffer. And to do that, we need to go GL frame buffer texture 2D. Cool. And here it takes the first is the target, and that's the GL frame buffer. Now the second is the GL enum for the attachment. Okay, this will specify the point in which we want to attach. And for our case, we're not going to have multiple attachments, but you can have multiple attachments. But we're going to use GL color attachment 0. Okay, and then there's going to be the texture or the texture target, which is GL texture 2D. Texture 2D. And then now we actually want to go GL uint texture. Well, what that means, it's not the texture, but it's the texture ID. So we need to go MP texture get ID. And then the last one is the GL int level. And that specifies the bitmap level, the texture image to be attached. And this must be set to 0. So I'm not sure why that is there anymore, but it must be set to 0. Okay. So we have that. Now, once we created the frame buffer texture, we can also create the render buffer object if we're going to use it. Now, in our case, the render buffer object will be something that will store the depth info of the frame buffer. Okay, so we'll go if mb use RBO. Then we'll do the render buffer stuff in here. And just like creating a frame buffer or a texture, it does the same idea. So you go GL create render buffers, and that would be 1 because it takes in the size, and then the address or a pointer to the render buffers, and that's the render buffer ID. RB RBO ID. Cool. And then in order to do something to the render buffer, we need to bind it. So we need to go GL bind render buffer. Then the target must be render buffer. GL render buffer, and then our render buffer ID. Cool. And now that it's created and bound, we need to create its data storage. And for that, we must use GL render buffer storage. So we go GL render buffer storage. And this takes in the GL enum target, and that's going to be the render buffer for our target. And then the second part is the internal format. And for our render buffer, it's going to be using the depth component. So we're going to go GL depth component. And there's multiple depth components, but we're going to do 32. Okay. We take a look here. So there's depth formats right here. So these image this is all I did was look up image format for OpenGL. And the depth formats hold the depth or store the depth information. So then we have what makes 32-bit float depth texture particularly interesting is that the depth texture format can be used with shadows, texture, blah, blah, blah. Color formats cannot. So if we're ever going to use shadows and stuff like that, we need to have our depth component 32. Okay. There's all kinds of other stuff. I'll link all of this in the description as well. Same with render buffer objects. These contain images. They're created with frame buffer objects. They're optimized as render targets, while textures may not be optimized as render targets, okay? Render buffers also allow multi-sampling, but we're not going to get into that. So all of these, everything that we do today, I will actually add those into the description. Helpful links just to have a better understanding. I may not explain it very well. I can use the tool, but I may not be able to explain it exactly how you need. That's why it's always good to be able to read the docs yourself and be able to deduce the information that way. Because I remember being in school before and trying to listen to the teacher, and no matter which ways they said it, it didn't make sense until I started actually doing the work. And that's when it started making more sense to me, okay? Okay, so now that we have our internal format, now we need the width and the height. And that's just M width, M height. Cool. All right, now that we've created the render buffer storage, we want to actually attach it to the frame buffer object. And for that, we're going to use GL Framebuffer Renderbuffer right here. And that takes in the first target, and that's going to be a GL Framebuffer. Then the attachment, and this is a depth attachment rather than the color attachment above. The render buffer will be our depth attachment. So GL depth attachment. I'm having a hard time saying that today. And the second is the render buffer target, which is the render buffer. GL render buffer. You almost think like that doesn't, like these aren't needed. So frame buffer, render buffer, frame buffer, render buffer. We know that that's what we're doing almost anyway. And then we need the ID, the render buffer ID, MRBO ID. Cool. That's it for that. So now that we have created the frame buffer, its texture, and the optional render buffer object, we want to make sure that the frame buffer status is completed. So we want to go if GL check frame buffer status, GL frame buffer is not equal to GL frame buffer complete. Well, we want to do something here. We want to have an assert for now. Scion assert, and that'll just be false. Fail to create OpenGL Framebuffer. Or what we can do here, we can go std string error is equal to std to string and gl get error. Then we go Scion error, fail to create OpenGL Framebuffer, and we'll actually get the error here. And just return false. And if we made it here, we can unbind our frame buffer and return true. Bind frame buffer, that will be GL frame buffer, and that's going to be 0. And then return true. Let's go down a little bit. Return true. All right, cool. And down here in our destructor, we'll just do the destructor now. It's pretty straightforward. So now if we initialize and we have our texture, we should actually have a valid frame buffer. So our destructor, every time you call create, so anytime there's a create or a generate or whatever, you also need to call its corresponding delete, or you're just going to add data on, and you're never going to delete your data or release your data. Okay, so you got to make sure that you delete it. So you want to go GL delete frame buffers, and we want 1, and we're going to delete the FBO frame buffer object. Then we check to see if we're using the RBO, and B use RBO, and we want to delete that render buffer. GL delete render buffers 1 and RBO. Cool. And then we also want to delete our texture, so we want to go auto texture ID, MP texture, get ID, and we want to delete that texture. GL delete textures. Delete textures. That's one texture, and we're sending in our texture ID. Texture ID. But before we do that, we want to make sure that our texture is valid. So if MP texture, then delete the texture. Awesome. And before we get into the resize and check resize, I believe we forgot to add 2 functions here. Yeah. So we need our bind and unbind, because we want to be able to bind the frame buffer and unbind it. So we're going to go void bind and unbind. Cool. Let's make these functions. Go into the, and binding and unbinding is just like everything else in OpenGL. You're going to want to call bind frame buffer, and it's going to be GL frame buffer, and that's our Ep.50. Copy this, unbind, and just bind it to 0. Cool. All right, so now into the resize and check resize. The reason that I did the resize and check resize functions like this is we currently don't have an event system implemented. However, I want to defer the resizing of the frame buffer while it's not rendering. We don't want to do it at the same time while it's rendering. We want to move it outside. I noticed if I did it before, it'll start to, you'll see the image flicker or flash while you're trying to resize. Well, we don't want that. So what we're going to do is defer it over. That's why we created that flag. So we go m width is equal to our new width, m height is equal to the new height, and then we want to set our flag, and it's going to be mb should resize is equal to true. Cool. And what we'll do here, so this is what will be happening while it's rendering. We'll just set it that we want it to resize. And then outside of the rendering, that's when we check to see if we have to resize. Okay, so we go here, if not, MB should resize, return. No need to go any further because we're not trying to resize right now. Okay, now this is where the work actually happens. Now I tried adjusting just the texture 2D, so like the text image 2D, and that somewhat worked. However, it started causing issues when you were resizing, like the rain that we have in the background right now, it just wouldn't be there. So it doesn't always work when all you do is it was changing the size. Everything was looking fine, except it would be missing certain things. So sometimes it's actually invalidated. So what we need to do is actually delete the old frame buffer, the old textures and everything, and then reinitialize it all with the new width. Okay, so we want to go GL delete frame buffers 1 on M.FBO. And we want to check to see if we're doing the RBO. So if MB use RBO, then we want to delete the RBO. Delete Renderbuffers 1, send in the RBO. Then we want to do the same thing where we're deleting the texture. Actually, we could have just copied all of this. That's what we'll do. We should put this all in a function to make it easier, a private function where we're deleting everything. And actually, that's what we'll do right now. So up here and initialize, and we'll say bool, and we'll say tear down or clean up. Clean up sounds better. Clean up. Cool. Make the cleanup function. Paste that in there. And then we can just use the cleanup function instead in 2 different places. Okay, so in here, instead of doing that, call your cleanup function. And right here, instead of doing this, call our cleanup function. Cool. Now that should delete everything for us. And then we're going to want to, first thing, I want to reset the texture. MP texture, set. And we want to create a new texture. So basically the same thing as we're doing here. I'm going to create a new texture, and this will be with the new width and height. Okay, we're not setting in the width and height here. It was already set here. So if we're getting to here, the new width and height have already been set. So we need to put those in there. Set width and height. Cool. And then we have our initialize, and we want to set MB should resize to false. Cool. Let's do a quick check here. So if not, let's just do an assert. This should work fine. Scion, assert, MP texture. Cool. New texture cannot be null pointer. Cool. And that's it. So what this will do is it'll clean up our texture. So delete everything, or clean up our frame buffer, delete frame buffer, delete the render buffers, and delete the old textures. Create a new texture here, and then initialize everything again to the new width and the new height that we're sending in. Okay, all right, that's it. That's basically it for our frame buffer. Now let's actually just go create a frame buffer right now. Now we're not going to see anything because we're not going to be rendering it to anything, but let's add it in. So go here into our application, and where's our rendering? Do we have anything rendering here? try to keep it as neat as possible right here. So include rendering, and this is in buffers, frame buffer. Cool. And inside of our initialize function, let's just create a temporary frame buffer. We got a lot of temp stuff, so we're gonna have to start getting a lot of this stuff out shortly. So we'll do that right here. It doesn't really matter where. I'll do it right here. So let's create temp frame buffer. So this is just going to be a simple test. We're going to want to have multiple frame buffers later on. So creating them this way is only for testing, because we're going to want a frame buffer for the tile map editor, for the scene, for the UI, different things like that are going to use frame buffers, because that's going to be basically our render target, and we'll be targeting it to a specific display. And we'll want to change those displays based on a checkbox or something of that nature, okay? For right now, we just want to make sure that it's all working. So we auto p frame buffer is equal to std make shared, and it's just going to be a Scion rendering frame buffer, and it takes in our arguments. It's going to be 640, 480, and false. Okay. We don't want to use RBO right now. We could, makes no difference. It's not going to show a difference to us in our game. And we'll actually do that later once we have it actually displaying in the display. So let's just check to see if our creating our frame buffer was successful. And we just actually copy this here. Failed to create test frame buffer. We don't want to keep going if our frame buffer is not working. So let's also add it into our registry. So MP registry, add it to the context, and it's going to be std shared pointer of a Scion rendering frame buffer. And that's going to take in our frame buffer, p frame buffer, cool. And we want to check if not, then we're just going to do another error, copy this again. We'll paste that in. Cool. Add test frame buffer to registry context. Chances of that happening as well. All right, so now that we have our frame buffer, we're adding it to the registry. Let's go down into our render function and add it in. Okay. Go here. So we'll grab it right here, and we'll say const auto reference FB equal to MP registry get context std shared pointer of the Scion rendering frame buffer. So we're getting our frame buffer, and the first thing I want to do here is actually bind it. Okay, we can take this stuff out for now, or let's actually move this higher. Take this, put this up here. Okay, and now that we have our frame buffer, we want to actually bind it right now. So we go FB bind. We're binding our frame buffer. Now everything that happens in here is going to be done through the frame buffer texture. Okay, so down here we can go FB unbind. Okay, not with, unbind. Cool. So now that we're binding our frame buffer, the viewport, all of these things here are happening inside the frame buffer. Let's change this to true, just in case we have a depth. So if we're using the RBO, we're also going to want to clear the depth buffer bit as well, because that's what that does here. Now, instead of using the window width for our set viewport, I actually want to get the frame buffer width here. So here we want to go FB width, and then FB height. FB height. Awesome. So now everything that's going in here should actually be going to our frame buffer now. So if we get rid of this for now, you shouldn't see anything on the screen because it should be going to the frame buffer. All of our draw calls in here should be rendering to our frame buffer. All right, let's run it. All right, so we have some errors here, and why complete must return a value. Why did I put that as bool? It's just, sorry. You guys probably caught that already. It should just be void. My bad. Run again. All right, so it looks like we have some errors here. Failed to create test frame buffer. That's probably something stupid. Knowing me anyway. So that was up here. Failed to create test frame buffer. Oh my lord. If not, yeah, you guys probably caught that as well. Awesome. So yeah, we have a big screen and nothing's being rendered to it. Everything's loaded. Everything's being rendered to the frame buffer right now. Okay, so now we're getting closer. Now we want to actually start this again with our DockSpace. Make sure that that's still good. Down here, let's not get rid of our DockSpace. Cool. And run this. Just to make sure that all works. I know I start a lot, but we got to make sure it works. It's faster than just writing a whole bunch of code and then trying to find your mistakes later on. Harder. It's harder to find mistakes later on. It's easier to do testing as you go. Iterative. Cool. So that's all working for us. We still have our dock. We can pull it here. That's exactly what I want. Cool. Let's just make this not that big. We're going to want to add our display here. So now let's create a temporary display for the scene. Okay. So up here, we can close all this for now. We can close that down. And in our editor, we're going to want to make some new stuff here. We're actually going to want to add a new folder here. A new folder. And it's just going to be the editor. And we'll make another folder inside of that. It's going to be add new folder. And that's going to be displays. We'll put all of our displays here. So inside of our displays, our first display is going to be the scene display. Now, this will change over time because later on, right now we're just loading all of our Lewis stuff right away. Like, where's our main? Where is it? Load main or whatever it's called. Load main. Is it load Lua? We called it something. I can't remember what we called it. Right. So after our Lewis state, not right here. Load main script. See how we're just calling that inside of our application? Well, we don't want that necessarily. Same with the binding. Each scene will have its own registry later on. This is going to turn out to be the main registry. Right now, we're just doing this all for testing purposes, but we need to get it all going. Eventually, each scene will have its own thing. And when we have our display, we're going to have a play button. And when we hit the play button, that's when it'll actually load all the scripts. Okay, so it'll load it at that moment, not right now. Right now, it's just loading it automatically. Well, we don't want to do that. Later on, we'll end up getting into that. But for now, let's create our scene display. Okay, so let's go add new item, header file, scene display.h. And that's going to have our editor namespace. So namespace, and it's going to be Scion editor. And now we need our registry. Okay, let's go include ECS. What do we call that? Let's go to application, go up to the top, core. Yes, makes more sense that way. So include core ECS, and we want our registry.h. Cool. Inside of our scene display here, we're going to want to say class scene display. We're going to have a private, and for now, this will change later on. But for now, we're just going to want the Scion core ECS registry, and we want a reference. we want a reference, we want it passed into us. So registry, and then we'll say public, and it's going to have our constructor, scene, display, just so we can set our registry. Scion for ECS registry. Destructor can just be default. And we're only going to have one function for now, and it's going to be the draw function. Void. That's it for now. This will change later on in the future. So let's create both of these. It's only two functions, two easy functions. So create both of these. Oh, let's go into it. Now we're going to have different functions later on. So for now, we'll move all this over. Namespace. With two functions, it's pretty easy. Otherwise, if you have many functions, just do the one and then copy it over. Cool. Let's do our registry. So M registry, send in the registry. Because you have to initialize all references. It can't be empty. Okay, so what are we going to need here? We're going to need our include ImGui. And then we're going to need to include our frame buffer. So include rendering buffers, frame buffer. Awesome. I believe that's all we're going to need for now. And let's just go into our draw function. Now, this is just going to be temporary. We're going to be changing this later on. So for now, we'll just say static bool key open. And then we're just going to have it default true. True's true. Then we're going to say if not ImGui begin. And it's just going to say scene. And it's going to take in the pointer of the bool. Be open. So it needs to take in the address of it. And if not, we want to say ImGui end and then return. And then we're just actually, as soon as we're done there, we want to take ImGui end and do it again down here, just so we don't forget, because it needs to have, for every begin for ImGui, it needs to have an end call. Okay. Now we're also going to have an ImGui child. That's what we're going to be wanting to use to render our image in. So we go ImGui begin child, and we'll just call this the scene child. And for size, we'll leave it as, we'll say ImVec2, basically be the same, vec2, and it'll be 0.f, 0.f. And then we'll say for flags, we have no child flags, so no. And then for window flags, I just want to say don't scroll with the mouse. So ImGui window flags, no scroll with mouse. Cool. That's good for now. And we'll just put this here into its own scope. Should we put it now? We'll just say if, and then put it in there. Cool. Since we only have one frame buffer and we just added that to our registry context, we're just going to want to grab that one frame buffer. Again, we're going to have a different way to do this later on, because you're not going to just have one shared pointer of a frame buffer. We're going to have basically get it from a map of specific frame buffers that we want right now. But right now we're just going to do the const FB, our frame buffer reference, is equal to M, const odd, but silly me, M registry get context. That's going to be our shared pointer of a Scion rendering frame buffer. Now we're not going to check it because we know that we put it in there and we know it's working. So what we're going to want to do now is get the window size, because I want to see if the window size, the current window size of the ImGui window is the size of the frame buffer. And if not, we're going to want to call our resize function. Okay. So we go ImVec2, and we'll say window size, and we'll just have that as ImGui get window size. And then we want to check now if our frame buffer width or height is different than the window size. If it's not, we want to call the resize function. So we go if frame buffer width is not equal to static cast int of the window size.x, or copy this, change this to y, change this to height. So if any of those, we want to go call the resize function, fb resize. Now it's not going to resize it here, okay? But we do want to send in this as a static cast here and y. So this is going to call the resize, but we're not actually going to resize it yet, okay? Now we want to set the cursor position. So ImGui set cursor pause, and we'll just set it to ImVec2 0.f 0.f. Cool. Now, previously, I used to have the frame buffer as a specific size, and then I would center it in the window. We don't really need to do that anymore. So now we can use the ImGui image function to render our frame buffer texture in the ImGui window. And that's what we're going to want to do here. So we go ImGui image, and this takes in a ImTexture ID. So we can go cast, we'll just do a C-style cast, ImTexture ID. And we're going to take our frame buffer, get texture ID. And then we want the image size, and this takes in a reference to the image size. So we can go ImVec2, and we want to do our image size, okay? Break this down a little bit, make it a bit cleaner. And for that, we're going to want to say static cast float of the FB width. Leave that there. Get rid of that. And cool. So now that we have our image size, and then we want to add in our UV value. So let's do this right here. So right here, yeah. So we want UV1 and UV2, and then the color. So we're not changing the color, but we do want to do our UVs. So I want to actually change that here. We want to go ImVec2, and we want to say 0.f and 1.f, and then ImVec2, 0.1.f, and 0.f. Cool. And that's all we're going to need for this, okay? And then right after the ImGui image, we want to say ImGui and child. All right. Now we could put this here, down here after the image. Actually, I think that's what we will do. Yeah, let's move this here. But we'll put it back if necessary. If not, we'll leave it as is. And we'll put it down here. So basically, check for resize based on window. Based on the window. Cool. All right, so that's all we're going to need for this one. Let's go back into our editor, or not editor, we're in the editor, application.cpp, and let's come down here, and then we'll just do some testing, more testing stuff. So include. Now we need to get our display. So displays, so it would be editor, displays, and we want to get our scene display. And just like the frame buffer, we're going to add in a test for the scene display. We're not going to do it this way later on, but for now, we just want to get that display and be able to dock it in our ImGui DockSpace. So down here, we're creating our temp frame buffer. Let's actually create the temp scene display as well. And for that, it's pretty straightforward. So auto p scene display is equal to std make shared. We want to make it shared because we're going to add it to the registry context as well. And it's going to be scene display. And when the scene display only takes in the registry as a reference, we need to dereference MP registry. Cool, that's it. Should work. We'll just copy all of this, put it here, change this to scene display. If not, fail to create pet scene display. Go down here. We want to add the scene display. Change this to scene display, not sealed. Scene display. Fail to add test scene display. Cool. So now that we have our scene display, let's go get our scene display and draw it in our ImGui stuff. So let's go here to render ImGui. And after our DockSpace, and right here we had our to-do, get rid of our to-do, and we want to get our scene display. Auto, reference P, scene display is equal to MP registry, get context, std, shared pointer of the scene display. And we know it's going to be there. If not, we wouldn't have been able to continue. It would have just closed our application for us. And then we want to go P scene display, draw. Now is the moment of truth. It should work for us. If not, we'll fix any problems that occur. That's right. Okay, so here's our display. Oh, look at that. There's our scene. And it's in the display. So there's a problem here. It's not changing size the way that we want. So it is changing size, but it's not changing. See how the world is changing as well? That's because we're not calling our proper resize function or check resize. So we're not actually changing our resize anywhere. It's only, so let's go here, just add that to there, full size this for now, close this down. And that's because down here, when we're doing our rendering, go back into our render function. We didn't actually call the check resize function. So let's call that right here before we swap the windows. We can actually comment this out for now, or yeah, just comment that out for now, or even remove it and put it somewhere else. Let's call FB check resize. And let's run it again. All right, so there's our scene. Let's move it up here. And it's showing that much. Let's change the size. Look at that, and it's showing the same amount everywhere. That's what I want to see. And if we take this, we dock it here, the same amount. We're running our colliders. It's moving. Colliders are working. The game is working now inside of an ImGui window. And that's what we want, guys. All right, so that's it for this video. And in the next video, we're actually going to, instead of moving back, continue with ImGui and scenes in the editor, we're going to go back to creating the quick game that where we use physics and add some different things in. The whole point of creating a game engine is to be able to create games, not just an editor, right? An editor is nice to have, but if you can't actually create a game with it, what's the point, right? So now we're actually doing the scene inside of the editor, just like we want. We can change the size of it and it works. It's by itself. You can actually take the window and move it over here. Oh, and here's another thing. Check this out here. You see our process memory? See how it's shot up right there, right? That's because right here, if we grab our scene, and it's right here, let's see what it is, 166 megabytes, right? So if we change the size of it, it's gonna shoot up all around. And see how it's shooting up, but the goal is for it to come back, because it's gonna be creating the frame buffer and doing all these things, then it's gonna be releasing and deleting those textures and frame buffers down here, back to 166 or 165 even. Right? So that's what we want. We don't want it, so say we forget to delete stuff, it could cause issues there and we don't want that. All right? So yeah, now it's up to 500, bang, back down 178, and it should drop even further. So yeah, you want to make sure you're not getting any memory leaks and stuff like that. Still maintaining 179, but anyway, that's the point. And let's open this up. Let's dock this again. Move this, dock it, cool. Now, this is without using the or RBO, or the render buffer object. So let's close this down and just set it to true. It won't make any difference, but we're going to put it in anyway, just to make sure that that's running. True, creating our render buffer object, and run. All right, yeah, so see, we have the render buffer. Didn't make a difference. All that it's going to do is actually cost more memory. So if we go to here, yeah, we see our memory here. So if we move this a little bit, grab this here, and we look at our memory, now we're holding on to more memory because we actually are creating a render buffer object as well. So we move this around a whole bunch. Remember, it's resizing each time, right? So it's going to use a lot of memory. But then it's going to drop right back down because it's going to be deleting all those things that we're calling the delete function on, right back down. Cool. All right, that's it for this video, guys. I hope you enjoyed it. Please leave a comment and a like below, or subscribe if you haven't already. And in the next video, we're actually going to be continuing to work on the game, maybe start adding in some enemies and some different physics, and actually start to split the game up better. Right now, we're just doing a bunch of temporary stuff. So let's actually create a character class and things like that. But these classes will be made in Lua. So that'll be a little test for you. Maybe try it out, see what you can do. Hopefully you're able to get the docking working and everything like that. All right, take it easy.